Today's lesson is 3.1, Properties of Absolute Value Functions. Let's go ahead and recall the definition of the absolute value. The absolute value is the distance a number is away from zero on the number line. So here in my example, much like your warm-up for today, the absolute value of 4 would be positive 4, because if I take a look and I put a dot here at 4, and I look at how far away it is from 0, because this is always our center, I guess, we would count it as 1, 2, 3, 4. Likewise, negative 4, which is right here, is also 1, 2, 3, 4 away from 0 as well. Distance cannot be negative, and so it doesn't matter whatever number is inside of the absolute value bars, it always comes out positive because we're really truly thinking about that as a distance. And one thing we learned in geometry is distance cannot be negative. Today, we're going to talk a lot about graphing our absolute value. So we're going to go ahead and start with graphing the parent function of our absolute value, which is simply f of x equals the absolute value of x. Remember, f of x is the same as your y equals, and so f of x is just my y value. It's just function notation. So we have a nice little chart here. And if we're filling out the chart by hand, we would put the absolute value of -2 in, and it would come out as +2. We would put in the absolute value of -1, and it would come out as +1. 0 would come out as 0. +1 would come out as +1. And +2 would come out as +2 because they are 2 away. If we went back and looked at our number line. Okay, so let's go ahead and graph these points. Remember, this is your x-axis and this is your y-axis, and your ordered pair is right here and here, because remember, this is your y value. So we're going to go to -2 on the x-axis and up to +2. Right there. We're going to go to -1 and up to +1, 0 and 0, the origin, +1 and +1, and +2 and +2. Notice that just like my quadratic, I have symmetry on each side. This side of my absolute value is going to mimic this side. There is what is called an axis of symmetry. The axis of symmetry, let me make it a little bit thicker here so that you can see it. It goes right through the vertex, which is this point right here. This point right here is called my vertex. It is the highest or the lowest point on my graph. For this one, it is considered a minimum. But if my graph were flipped upside down, let's say my graph looked like this, then my vertex right here would be considered a max, because my graph is going in a downward direction. My vertex for this one is, of course, the ordered pair 0, 0. My axis of symmetry is the line, the vertical line that goes right through my vertex. Since it is a vertical line, it has the equation x equals, and it's simply the x value of your vertex. If you look at your vertex right down here, the x value is 0, so my axis of symmetry would be x equals 0. We can talk about our graph increasing and decreasing. Um, when I do this, to determine if my graph is increasing or decreasing, I simply have to read it much like I would a sentence. So I start on the right-hand side of my page. Let me change my color. I'm going to start over here on the on the left side of my graph, and I'm going to read it to the right side, or just like I would a sentence, left to right, not right to left like I tried to trick you with. So if I read it that way, starting up here, my graph is coming down to the vertex. My graph is coming down to the vertex. So I would say that this side is decreasing. This side is decreasing. It's coming down to the vertex. At the vertex, it is neither decreasing nor increasing. This is a turning point to where my graph is going to start going in an upwards direction. So here I would say my graph is increasing. We can also talk about the domain and the range of this graph. Remember, the domain are your x values. So here's your domain. Now, this is only a small chunk of your domain. Remember, what you really want to do is look at your x-axis, and you want to take your graph and you want to flatten it to that x-axis. So you already have the vertex on the x-axis. You're asking yourself the right side, is it ever going to stop? No. So it's going to come over here. And remember, positive infinity is always on this side when the arrow is there. Then you're going to ask yourself, what about the left side? Is it ever going to stop? No, the arrow says it does not stop. So that would flatten down to this. Remember, over here on the left side is negative infinity. So I would say that my domain is negative infinity to positive infinity. Now the range are your y values, remember. Now, the range is going to be dependent on your vertex. The range will be dependent on your vertex. So you're going to look at the y value of your vertex, and then you're going to ask yourself, is the graph above that or is it below that? Where's the graph? Is it above your vertex or is it below your vertex? So if I look right here, my graph is going upwards, so it would be above. The infinity that's up here, because notice my graph is never stopping going upwards, is positive infinity. If my graph were going like this, then it would be going downwards, and the infinity down here is negative infinity. So just a quick reminder, this is positive infinity. This is negative infinity. And it's just, where's the graph pointing to? Well, this graph is pointing towards positive infinity. So I would say my range is 0, comma, positive infinity. Remember, positive infinity always gets a parentheses. And with the 0, we have to decide, is it open or is it closed? Is it part of the graph or is it not part of the graph? Well, that sure looks like a closed circle to me, so I'm going to go ahead and use a bracket. Oops, let's try that again. There we go, a bracket. That would be my range. Don't worry, we're going to practice this more as we go through. I just want to go back and add that this is negative infinity and this is positive infinity for you for the x-axis. Okay, let's go ahead and remind ourselves about vertex form. We've seen this before. This is the vertex form of a absolute value function. What these letters represent are my function and how it is transformed. So remember, f of x is your y. This is your y. You have to have this to have a function. X, remember, is the other part that you have to have a function. This is your parent right here. The A, the H, and the K are going to tell me different things about what my graph is doing before I even graph it. So my A value right here. Well, if the absolute value of A is greater than 1, it is going to stretch out my my function. What that's actually going to do is it's going to mean that it's going to get narrow. Okay? If this A is between 0 and 1, if the absolute value is between 0 and 1, it's going to compress my function, which means my function is going to end up getting wider. Okay? If this A value happens to be negative, then it is reflected over the x-axis. Sometimes you see the word flipped instead of the word reflected. But for your assignment today, I did use the word reflected when A was negative. Just a reminder, I did use the word reflected, not the word flipped. All right, H and K are going to tell you if you're going to move left or right, up or down. Okay, remember H is tricky. H is tricky. The formula for it says minus. So when H is negative, it's going to look like a plus. When H equals -3, it's really going to look like a +3 in here. And when H equals +3, it's going to look like an X -3. K moves your graph up or down. K moves your graph up or down, and it looks exactly how you think. So if K is 3, then it's going to look like +3. If K equals -3, then this is going to change to a minus, and you're going to see a 3, which moves you down. Now remember, it's different. This is a movement to the right. This is a movement to the left. Okay, so just remember that H is tricky. But H and K, they are the vertex of this graph. Now remember, you have to keep in mind that H is trying to trick you. So when H is negative, it's really positive. When H looks like a -3, it's really a +3. And when H looks like a +3, it's really a -3. So you just really need to be careful with that. And X equals H is the axis of symmetry that we saw in the last graph. Oh, I see. I know what goes in here. Sometimes we see this as axis of symmetry, AOS, so we don't have to write it out. All right, let's go ahead and take a look at two more graphs with translations. And just to remind you, when we talk about increasing or decreasing, I know I said it in the last slide, but to determine if we're increasing or decreasing, we're simply going to read our graph from the left to the right side. But let's go ahead and graph it first. Now, one of the things that you can do is you can say, right? I can always put that right above. I guess I don't really need the equal sign. I'll go ahead and get rid of that. But there we go. Now I can see who lines up with who and what A is, what H is, and what K is. So I'm going to go ahead and say H, comma, K, and I'm going to figure out what the vertex is right away. Well, H appears to be this number right here. And I need to be careful. It does have a minus in front of it. So is it +2 or is it -2? I have to remember that it's trying to trick me. It looks like it's -2, but it's really +2. And K should be right here because notice how H was right there. K should be right there, right? Let me show you with my color. There's nothing. So I have to think, what number is nothing? 0, you guessed it. So there is my vertex. And I could even go ahead and say the axis of symmetry is X equals 2. So right here at 2 on my X axis, there is a vertex line. There we go. There is my axis of symmetry. Here is my vertex. And now let's go ahead and let's just figure out what the other points would be. So I'm going to go ahead and make a table. And honestly, could you get this from the calculator? You sure could. I'm just going to go ahead and show you by hand because I don't have the fancy calculator here in the video. All right, so what number should I pick? Well, 0, 1, 2 because that's my vertex, and 3 and 4 are good choices. That gives me um, that gives me 2 on either side of my vertex. Now I know right here at my vertex, I already know this answer is 0, but 2 minus 2 is 0, and the absolute value of 0 is 0. So there we go. So I already knew that that was my vertex. I could get 2 on this side. 0 minus 2 is negative 2. The absolute value of negative 2 is positive 2. So 0 and 2. The axis of symmetry says since that point is 1, 2 away, there's 1, 1, 2 away on this side. So I should have a point right here at 4, 2. Let's go ahead and see. Let's go to the bottom of the table and let's see if that is true. 4 minus 2 is 2, and the absolute value of 2 is 2. Look at that. There we go. Let's go back up here. 1 minus 2. 1 minus 2 is negative 1. The absolute value of negative 1 is positive 1. So 1 comma 1. The axis of symmetry says since that point is 1 point away, there's 1, 1 away on the other. I should have a point here at 3 comma 0, at 3 comma 1. Let's check it out. 3 minus 2 is 1. The absolute value of 1 is 1. And yes, the axis of symmetry works. So what the axis of symmetry does for you is it allows you to graph faster. You only need a couple of points on one side, and then you just reflect them over the axis of symmetry. Remember, when you're reflecting, you're simply counting 1, 2, same distance, 1, 2. That's all you're doing. Let's go ahead and create our graph so that we can talk about some stuff that is going to show up on your quiz. All right, so here is my vertex. We've already established that. And we have the ordered pair up above. This vertex, we have to decide if it's a minimum or a maximum. Is it the highest point of my graph or is it the lowest point of my graph? When you do this, you are reading your graph from the top to the bottom. So this would be considered the top of my graph, and this would be considered the bottom of my graph. Well, this would be considered the lowest point, so this vertex is a minimum. This vertex is a minimum. Where is my graph increasing and decreasing? So remember, we're going to start over here on the left side of my graph, and we're going to read it to the right side of the graph. So the first points I see are right here. The graph is going in a downward direction to the vertex. Even though the arrow is pointing this way, I have to start reading the values. And as I start reading them, because they even come up here, I'm coming in this downward direction towards this point. So this side of my graph, sorry, there we go, is decreasing. Once I go to my vertex, I'm no longer increasing nor decreasing. I'm going to turn and I'm going to start reading in this upwards direction, which would be considered increasing. So just remember, downward is decreasing, upward is increasing. They both start with a vowel. There we go. All right, the last thing we need to talk about are the domain and the range of our graph. Remember, these values right here represent your domain because X is always your domain. But remember, you're really taking that graph and you're flattening it to this X axis. Remember that over here on this side is negative infinity, and over here on this side is positive infinity. You want to use your vertex as a starting point. You're going to take that vertex and you're going to, in your mind, pull it to that x-axis, right to this axis right here. There we go. I'll make it blue for you. Well, it's already there. It's already there. So you're just going to ask yourself, what is the graph doing to the left? Is it ever stopping? The arrow says, no, I'm never going to stop. So that's going to come and flatten right here like this, which means I have negative infinity as my leftmost point. Then you're going to ask yourself, what is the graph doing to the right? Well, is it ever stopping? No, it's going to come and do this, which means you have positive infinity. Just a heads up, the domain should almost always be negative infinity to positive infinity. There's only rare occasions where it's not, and that's when we put restrictions on our graph. We would actually have to say we're only graphing it from this point to this point, this interval to this interval. That's the only reason your domain would not be all real numbers. Your range are your y values. So here is your range, which are your y values. So let's look at our y-axis. Remember in our y-axis, oh, let me make that a little bit bigger. There we go. The negative infinity is down here, and the positive infinity is up here. Remember, we read the range from the bottom to the top, but really the absolute value is the easiest one to do because you're just going to look at your vertex. So find your vertex, look at its ordered pair. Which one is the y value? This one right here. So the range has to contain that number. It has to contain the y value of your vertex, okay? It has to contain that number. And then you're going to simply ask yourself, look at the arrows. Are they pointing towards positive infinity or are they pointing towards negative infinity? Where are the arrows pointing? These arrows are pointing towards positive infinity. So I'm going to use 0 and positive infinity. Well, I know that positive infinity always goes second. Notice right here, positive infinity is always second, negative infinity is always first. So I'm going to put 0 first and then positive infinity. I know that infinity, whether it's positive or negative, always gets a parentheses. The 0, I have to look at the point. Is it open or is it closed? Well, there's no restriction on this graph, so it is closed. I'm going to use a bracket, and that's it. All right, let's try one more. A little bit tougher this time. Oh, let me grab this one. So I can go ahead and I can already decide what my vertex is by simply doing this. So I can find my vertex. Let me see. We can figure out the vertex right away by simply saying this is H. Oops, nope, I'd use purple. This is H, and this is K. Now, I notice that this one is positive, but remember, it's tricking me. This is actually tricking me. So my vertex is really +3, +2. Remember, it's tricking me. It's totally tricking me. I notice here as well that this graph is going to be compressed from the um, from the fact that my A is between 0 and 1. It is a fraction. And I also notice that it's negative, so it should be flipped over. It should be flipped over and facing in the different direction. I also know that my axis of symmetry is x equals 3 because remember it's always x equals h. So right here at +3 is my axis of symmetry. There we go. And at 3, 2, there is my vertex. Here's my vertex. right there. Okay, let's go ahead and make a little table. I'm going to make it a little bit smaller this time. I'm just going to have the x and the f of x, which are my y values. And let's see, 3 was my vertex, so 1, 2, 3, 4, 5. Now, how would I decide that? I could just go into my calculator, right, and put in the equation and then put Control T and look at the table, and I can find everything that I need. When I put this in, I'm going to get 1 and 1. So 1 and 1. There we go. I'm going to see 2 and 3.5, or 1.5. So I'm going to do the best I can. There we go. I probably wouldn't have put that one. 2. Now, because of that axis of symmetry, I know that there should be another point right here. So this should be my next point at 4 and 3.5. And it shows up in my calculator. That should show up in my calculator. And then I also know that since this one is 2, there's 1, 2 on this side as well, 5 and 1. And that shows up in my calculator as well. So here is what my graph looks like. Let me do the best I can. There we go. It's going to continue downward, and then of course this side would continue downward as well. It looks a little funky, but there we go. My vertex in this case would be considered a maximum. This one would be considered a maximum because it is the highest point in my graph. If you look at your graph from the top to the bottom, this is the highest point, and the arrows are pointing to the word bottom. So that means it's a maximum. It is a high point of your graph. All right, let's talk about where I'm increasing and where I'm decreasing. So remember, we're going to start reading over here on the left side of our graph, and we're going to read towards the right side of our graph, just like we would a sentence. So if I read this graph, even though it is pointing in this direction, I would read it going towards the vertex. So this side of my graph, since it's going upward, would be considered increasing. At the vertex, we take a turn and we start reading in a downward direction to the right side of our graph. So this side would be considered decreasing. Okay. All right, what's left? What's left? The domain and the range. So remember, your domain are your x values. The domain are your x values. And just like I said, it should be negative infinity to positive infinity because you should see those arrows on either end, and you do. You see the arrows on either side. This vertex is going to come down here along the axis of symmetry. This side of your graph is going to get pulled in towards negative infinity, and that side of your graph is going to get pulled in towards positive infinity. So once again, negative infinity, comma, positive infinity. Remember, with your range, which are your y values or your f of x values, you're going to use your vertex. You're going to take a look at your vertex, and you can look at it right up here, and you're going to pick the y value. Remember, this is always the y value. So you're going to use the number 2, and then you have to pick your infinity. Which infinity is this one pointing towards? Well, look at your y-axis. If it's pointing up here, it's positive infinity. If it's pointing down here, it's negative infinity. So let's take a look. Here is my vertex, and I'm pointing in this direction. Which infinity am I pointing towards? Negative. My graph doesn't even exist up here towards positive. So I have to use negative infinity and 2. Those are the numbers I have to use. Well, negative infinity has to go first because it is smaller than 2, and then 2 goes second. Infinity, whether it's positive or negative, always gets a parenthesis. And the 2, I have to decide, is it a point on the graph or not? Is it open or is it closed? It's going to be closed, and so I'm going to use a bracket. All right. Our last example today is how can I write the equation of the graph when I'm just given what the graph looks like? So write the equation of the graph. So I can find the vertex on this graph. My question is, how do I find A? How do I find A? So I'm going to use this right here to write my equation. Let me go ahead and get it all ready. Sorry about all the different colors, but there we go. I'm going to use this vertex form to help me out. There we go. And then remember, there could be a negative right there as well. All right, so the big question is, I can find H and I can find K. Let's go to the graph right here. And I just need to know the vertex. There it is. There's the vertex. It appears to be, let's see, -1, 1, 2, +2. So there we go. If I look at this, this is going to be H and this is going to be K, right? So this is H, this is K. So I already can come in here and I can say f of x equals, I'm going to leave some space because I don't know. It's going to be minus a -1. A double minus is going to change to a plus, and then +2 because it's a +2. The only thing, oh, excuse me, is how do I find A? How do I find A? Well, A is simply the slope of the right hand side of the graph. It's simply the slope of the right-hand side. So let me grab that orange and let's find the slope of the right-hand side. Well, here's the right-hand side of my graph, right? Because here's my left, here's my right. All I have to do is rise up and run over. So I went 1, 2 up and I went 1 to the right. Everything is positive. Everything is positive. So I'm going to say that A equals 2 over 1, rise over run. 2 divided by 1 is simply 2. So I'm going to go ahead and put a 2 right here. How do I decide if it's negative? What's my vertex? Is my vertex a max or is my vertex a min? Well, this vertex is a minimum, right? That means A is positive. If we go back and look, what makes a maximum? A is negative. A is negative, and then I have a max. Oops, I got too. So there we go. We're done. There's the equation of our graph right here.